Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 119 and 120. We are discussing alternative standard states and we are almost finished. Only thing is this, that I will pick up, so far we have considered binary system and the relationship. If you notice that the relationships are actually, these are the relationships. I have actually, these here actually tabulated here, saved here. Relationships, the Henry's law line in three different forms, as I have already told you. And this is actually the relation between activity of B in terms of three different standard states: Raoultian, Henrian 1 mole fraction, and Henrian 1 weight percent, and their interrelationship. For example, this is between Raoultian activity, which we symbolize as AB, and HB mole fraction is Henrian standard state, Henrian activity of B, and this mole fraction type, Henrian mole fraction activity of B. Activity of B in terms of Henrian mole fraction standard state. This is in terms of activity of B in terms of Raoultian standard state. Similarly, this is again Raoultian standard state, and this side is Henrian activity of B in terms of Henrian weight percent, 1 weight percent standard state, and the last is obviously the remaining two, that is Henrian mole fraction standard state and Henrian weight percent standard state. All are actually representing activity of B. Symbols are different note. AB reserved for Raoultian activity, the conventional, the commonly used. So far we used it before this. Until this we use this Raoultian standard state. Okay, so symbol is AB. That is the pure state is the standard state for solids and liquids. You know this. And for gases, 1 atmospheric pressure. So this is the symbol reserved there, and the two different symbols came. One is HB mole fraction, that is activity of B in terms of Henrian mole fraction standard state. Another is HB weight percent, that is activity of B. That is activity of B in terms of, with reference to 1 weight percent, Henrian 1 weight percent standard state, H for Henrian. So this, and what we got here also, this interesting relationship, that Henrian activity coefficient, mole fraction type. Okay, that is actually Henrian mole fraction activity coefficient, A for activity coefficient. Remember, Raoultian activity coefficient, you know very well, that is gamma B. This is Raoultian activity coefficient, and Henrian activity coefficient is AB. Since there are two Henrian standard states, Henrian activities, so like with respect to two Henrian standard state, so like this HB mole fraction, there is a corresponding activity coefficient. Okay, and here also there is corresponding HB 8% corresponding Henrian activity coefficient. And for Raoultian also, what is the activity coefficient? We know very well, gamma B. So gamma B, these things. So when we actually concluded, we actually completed this discussion. It is FB mole fraction and FB weight percent. We showed that they are equal. Not only that, their value is gamma B by gamma B0. So far, binary system. Today we will take up ternary system, and we will consider whether these relationships are still valid. This is very interesting issue. That is, for ternary, what will happen? ABC ternary, or for that matter, quaternary, pentanary. So like this. So today we will discuss this. I will save this diagram for a while, and this very important 3-3-6 relationship, I will actually keep it intact alongside, and I will remove this. I have to No, I have to remove this. I have to remove this. I have to remove this. This has been very. So this actually takes some time. I see. This actually AB mole fraction. See, shall I save somewhere? Shall I save somewhere? Okay, this outcome. Uh, this equation 20 I'll write somewhere. I'll write somewhere. Okay. This only. But otherwise, this figure actually we have to keep intact. Figure is this. This figure is here. Activity of B. This is the diagram. Okay. We will not much refer to the diagram today, but let me remove this. Or this XP relationship, maybe said that is another thing that I saved. These are actually lengthy relationships, so it is better I keep them. Okay, keep them actually saved, and we can use later. So almost, I'm very sorry. Just these two I want to, apart from the diagram itself and these 6 relation and this last day, the conversion of mole fraction and weight percent in binary, though, and this is the one that is binary result. So that also I would like to save here. Just this place will be good enough. AB mole fraction, I am copying this. I am copying. AB mole fraction is AB weight percent is gamma B by gamma B0. Gamma B by gamma B0. This is actually this. Okay, I wanted to say. We'll see. We'll see. I tell you beforehand. I'll consider now ternary system, and we'll see that this relationship will be still valid. So there is no change. But that I have to demonstrate. We have to see this. I have to establish that. Otherwise, so let me actually write this. I have this is activity, not activity of B with respect to B as standard state. Raoultian activity. This is actually what I wrote. Raoultian. Okay. Raoultian activity. I have space limit, space crunch. Okay, so that's why I cannot. I have to make room for writing today's. This is Raoultian standard state. Just in case. This figure actually you have already noted, so no problem. Just you mark this actually. You mark this here actually. This border. This is the fencing. So try to make as much room as possible for today's writing, today's discussion. So I'm removing this since it is already. Oh, this equation number is 20. Would be good idea to is actually right here. This is this 20, equation 20. Equation 20. Okay, so this is okay, very good. All equations are marked here alongside. This is, for example, equation 1, 4, and this is 12, then it is 3, this is 11, and this is 15. Now this is 20, and other relations are already used. So I am removing this. Start. So today, alternative standard state. What I say? Alternative standard states continue. Solution thermodynamics continued. Later on, I will remove this. Let me write once. Solution thermodynamics continued, and alternative standard states continued. Okay. So today we consider the main thing is this ternary system. So let us write a few lines that so far we have considered binary system A-B. Binary system A-B. We will next consider a ternary system A-B-C, ternary system A-B-C, and examine the expressions for AB mole fraction. You know, AB, remember A is activity coefficient, H is activity, Henrian. Two types, AB mole fraction and AB weight percent. Likewise here, HB mole fraction and HB weight percent. These are activities, these are activity coefficient corresponding. And for Gaussian, what is the activity? AB. What is the activity coefficient? Gamma B. So for AB mole fraction and AB weight percent. So this here you see for binary. This for right here somewhere binary. This is for binary. And you remember this is for binary. You see AB is there. So binary. This is okay. This all are binary. Now, okay, I'll talk on this. Okay, AB mole fraction, AB weight percent, and check if AB mole fraction is AB weight percent if the equality right here, if the equality equality AB mole fraction is still holds. Still holds. This is our job today. Then we will finish alternative standard stress discussion, and then we'll take up an assignment based on alternative standard states. Assignment problem today itself. So let me finish first. Okay, first is this start. So first I start with see this and this separately. AB mole fraction I am working. See what relation we get for AB mole fraction. Okay. See here gamma B by gamma B0. Let us see here. Start. What is this activity of B? I am writing this in notebooks. Activity of B is gamma B XB ABC ternary. Obviously, activity of B, say here, activity gamma B XB, since this is binary, but here the deviation from Raoult's law. Deviation from Raoult's law in a ternary, what you write? If it follows Raoult's law, if it actually accord with the Raoult's law, then what you write? Activity of B is XB ternary. No problem. No problem. If it is not, introduce gamma B as before. Only you added today ABC ternary instead of AB binary ternary. Multi-component I am trying to address. I am trying to address multi-component. So ternary may be the first one, okay, or beginning one. So if the principle we can find out, then we will see this. We can actually extrapolate it to, extend it to for other multi-components. Start. AB is gamma B XB. Now you see, and what we have, AB is HB mole fraction gamma B0, because this is actually two standard state. Yeah, this one I am writing. Equation 3. See, equation 3 I am writing. So this is actually about activity of B in terms of two standard state and the relation. This is gamma. They are separated by gamma B0. This we know here. Okay. So from these two, hence we can write this HB mole fraction is what you can write. HB mole fraction from this is gamma B over by comparison gamma B0 gamma B0 times XB in ABC ternary, right? XB in the ternary, in ABC ternary. Okay, this we get hence. And what relation we have with this? And we know what we know. If there is a deviation from the Henry's law is what we get HB. We know. It is better right, but HB mole fraction is AB mole fraction XB ABC ternary. Follow this. XB is about ternary XB. Ternary XB in the ternary ABC rather than AB as in the last case. No, this time it is ABC. HB is this. If the Henry's law were valid, for this HB would be XB, but not valid deviation, AB mole fraction. What is this? XB ABC ternary. Actually, you write this. This is the equation. What is this? You may write this. This is the note. This is the equation. This is the equation for the deviation from Henry's law. For the deviation from Henry's law. Henry's law line in ternary system A-B-C. In ternary system A-B-C. Now, what you get this? Compare these last two relations. Comparing the last. Comparing the last two relation. The last two relation. What you compare? Left hand side is the same, or with and XB same. We can conclude. We get AB mole fraction is gamma B divided by gamma B0. Very interesting. Same as binary. Same as binary. So you can note that same. You box this. Same as that for the binary. Same as that for the binary system AB. So this part is over. One is over. And next is AB weight percent. Take up that. AB weight percent is the next one. Okay. You start with this HB weight percent and HB mole fraction. Okay. HB start. I'm writing this. Actually. HB mole fraction is AB mole fraction. You know, XB, what shall I write? Since mole fraction in the ternary, ABC ternary. ABC ternary. Now, what is this? Keep on writing. Is AB mole fraction. AB mole fraction. What is the XB in the ternary? Recall conversion of interconversion of mole fraction and weight percent. Mole fraction and weight percent previously, or mole percent and weight percent. So what is this? Recall this. Recall. Where I will ask you recall. Shall I write somewhere here? I think you don't mind now. If I can I write here? Or it will be clumsy now. If you clumsy, maybe this side, little bit. XB is what? XB is what? Here, follow. XB is what? Tell me. Little bit. Good enough. XB is what? Weight percent. Recall weight percent B divided by atomic weight of B. Remember this. XB weight percent atomic weight B divided by weight percent. Okay, B by A. You can write weight percent A by atomic weight A plus weight percent B over atomic weight B plus weight percent C. Recall this first class of solution thermodynamics. Weight percent C, atomic weight C. What it will give you? I am writing. You check this. Atomic weight percent B, atomic weight A, atomic weight C. See, this numerator will be atomic weight A, atomic weight B, atomic weight C, the LCM, and here atomic weight B. So cancel out atomic weight A and atomic weight C goes top, and here you will get actually, for example, write this weight percent A, atomic weight B, atomic weight C, one term, atomic weight C plus weight percent B, atomic weight C, atomic weight A, or atomic weight AC, okay, you may write, since I have written here, this way you may write, okay, plus weight percent C, atomic weight A, atomic weight B. Here this is saved for ternary, shall I write here? For ternary A-B-C, yes, this, ternary, understand this, okay, this is, and you see XB is what for binary? This one, this, this, atomic weight percent B, here atomic weight A, weight percent B times atomic weight C, numerator, and denominator you can clearly see this difference. So put it back into this. So this, let me write this, weight percent B, atomic weight A times atomic weight C over, I have to accommodate three terms, denominator, weight percent A, atomic weight of B times atomic weight of C plus weight percent B, atomic weight of A times, oh sorry, very sorry, I actually want to make the fencing, okay, atomic weight A times, what is this? Where I have, yeah, atomic weight C, so still narrow here, fencing is actually reducing it, okay, and so that I get more room actually here, plus weight percent C, atomic weight A, atomic weight B. So this is also actually, yeah, we have saved for ternary today. First we have saved this ternary, okay, this one. Remember this is already written here, so or you may save here, okay. This is for ternary, same as that for binary, and we are discussing ternary system. I have written somewhere here ternary system, underline ternary system A-B-C, today's topic, okay, ternary. So I have written here repeatedly. So this is AB. Now what is HB weight percent? Take up this HB weight percent. Let me write this first. Let me write this, that will be helpful. Okay. You write this HB weight percent is HB weight percent. HB, say this, and times, then it will have actually atomic weight. I'll prove this, atomic weight of A plus 99 atomic weight of B times atomic weight of C, and the denominator will run similarly. And oh sorry, it's okay. It's okay. And what is this? It runs similarly. Weight percent A, you write weight percent A, atomic weight B, atomic weight C plus weight percent B, atomic weight A, atomic weight C, and plus weight percent C, atomic weight A, atomic weight B. Very good. Times you put a bracket here. One important is what it will be, HB weight percent will be times, what is HB weight percent? HB weight percent is what? This times weight percent. This times weight percent, binary. Now this is actually modified. See, numerator, this term still there times atomic weight C, and likewise this denominator is actually modified by 3 terms rather than 2 terms. So this is easy. So shall I write here? I hope I will get a, oh, this is bracket. This is bracket. Then this is very important. So I cannot avoid this. Again, try to shrink this and write weight percent B. So this thing. This is the weight percent B. Yeah, here like this, as I told you. Here for binary, it's the weight percent B. Is it okay? Is it okay? This is atomic weight A, atomic weight C. C is weight percent B. Okay, huh? This is weight percent B. I hope you have got this. Okay. Now, how? How obtained? This is the proof demonstration here. How we get this? You start with this activity of B, gamma B0 XP. You have no doubt. Activity of B is gamma B0. I'm very sorry. Gamma B XP. I'm very sorry. Activity of B is XP ternary. XP, gamma B0 XP. Very good. Equation for Henry's law line. This is equation for this one. Equation for Henry's law line. Okay, this is Henry's law line. Okay, this we know. But here you should apply suitably. What is this gamma B0? XB. What is the XB here? For ternary ABC, and XB at ternary ABC is what? You write that out. Is what? Shall I get a space? I hope I will get. Is gamma B0 XB ternary is this expression. Let me write this. This I am copying. Weight percent XB, weight percent B times atomic weight A, atomic weight C divided by weight percent A, atomic weight B times atomic weight C, okay, plus weight percent B. You know actually now, but I want to write full length. I can easily give sigma, but it's better I write weight atomic weight C plus last is what? Here weight percent C plus weight percent C plus weight percent C atomic weight of A times atomic weight of B. Easy to be. There is actually system here. Weight percent A, atomic weight of B and atomic weight of C. Weight percent B, atomic weight of A and C. Weight percent C multiplied by atomic weight of A and atomic weight of B. So this is easy to remember. Okay, very good. So XB is this. XB has been copied from here. Okay. So now this is okay. One thing. Now again, what you have? Activity of B and we are interested here. Activity of B is what? HB weight percent Activity of B is HB, two relationship, HB 8%, gamma B0, write this, or write, you can write at the beginning, let's copy this, is gamma B0, atomic weight of A by atomic weight of A plus 99 atomic weight of B, okay, very good, very good, very good, times HB 8%. If you are interested, write equation 11, okay, equation 11. Previously, this equation, okay, 11. See, this is what, why I have not brought in here, see, all AB, in terms of AB, because this is the relation between two activities. Activity of B, in terms of two scale, two standard state. What are they? Raoultian, Henrian, weight percent. Raoultian, Henrian. So this is standard relation. Standard relation, this relation. This relation was already there. Now this is actually what is its origin? The origin of the standard states. Standard states are defined. Repeat, standard state. Standard state. First, Raoultian, right here. Henrian, mole fraction, right here. Henrian weight percent, right there. Refer to binary. And this is fixed. This cannot be changed. So, because its origin is the binary, so this is when you consider ternary, this relation always maintained, always holds, because origin is this. Okay, so this is already established. So you can write these lines actually if you are interested. Okay, this. So always valid, right? Always valid. This is about two standard state change relation. Standard states are actually beginning at the beginning defined in terms of binary system and source. In a binary, this will be the Henrian standard state. This will be the Henrian standard. Extrapolation to XB1, non-physical and okay, hypothetical. This is Raoultian pure state for binary, and this is the Henrian weight percent, which is in the on the Henry flow line. On the Henry flow line. So these are standard. Their relationships are standard. So and must be originated from the binary system. Hence, AB shows here. So you may write this. Now the relation between these two standard states always valid. Okay. This I write. Now the relation between the two standard states is better. You will understand. Now the relation. What I'm trying to get here. Now the relation between relation between I'm writing here between the activity of B with respect to which Raoultian standard state AB and Henrian weight percent, right here, weight percent, Henrian weight percent, standard state, or HSS weight percent. That's it. Now this is the relation. Always valid. What I am going to write here, because the origin is Oh, I should have written here. Acha, and because its origin is AB binary. Always valid means this is always valid. Always valid because standard state relations. Standard state of where? Go to the binary and show the standard state. How to go to the standard state? In a binary, they are defined. How they are defined is that this is a binary diagram. They are defined Raoultian, Henrian mole fraction, Henrian. Clear. And what is the difference between the standard free energy or free energy? That is standard free energy is their standard state. So standard free energy. The difference. This we did. Finally, we got this type of relations using those things. This. Actually, another thing I should write here. That's why here I missed this. This one. This one. Here, please. This. Actually, this one. Last time it was very simple. AB is HBMM gamma B0. Equation 3. I wrote. Why I wrote? This is ternary, but it is right here. This star goes there. Fortunately, I have some space here. This I am writing actually elaborately. This I am writing. The origin. This is actually again standard state relation. Activity of B with respect to Raoultian, activity of B with respect to Henrian mole fraction. The relation. They are related through gamma B0. Separate. And here, not only gamma B0, but additional factor because it is weight percent. All along we are seeing this. So, just write this. This I am writing elaborately. This is, I forgot to write, this is the relation, right? This is the relation this is relation between the two standard states. Between the activities activities of B. Activities I am writing. Activities of B with respect to the standard state. Two standard states. This is activity of B. 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 This is with respect to Raoultian. This is respect to Henrian. Of with activities of B. The relation between the activities of B with respect to the two standard states. The two standard states. Who are they? Tell me. Write this. States. What right? RSS, Gaussian, and HSS. Henrian standard state. But you should specify mole fraction. Mole fraction is one mole fraction. Mole fraction is this one mole fraction. One mole fraction. I write in short mole fraction. One mole fraction. 8% standard. 8%. On the Henry line. Both are on the Henry line. That's what I have written. They are not completed yet. I write this. Very good. What is that? With respect to the and O's as I am writing and O's its origin and O's its origin where in the binary. Its origin to the binary system AB. To the binary system binary system AB always. Please note this. Please note this. Giving bracket. Please note this. I repeat. This is like this. This is same here. It is in here. What? Here. How is HB mole fraction? This is HB with AB. Additional terms complexity because one weight percent standard state is a more complex than one mole fraction standard state. So what I have written here, this is the relation. This is this one. If clearly see, you say two activity relation, two activity of same stuff B with respect to Gaussian standard state and Henrian standard state. Okay. So this is the relation between the activities of B with respect to the two standard states, RSS and HSS MF, and owes its origin to the binary system AB always. This one, write first one. Equation 3 I can write also. If you like me, equation 3. Okay, somewhere. Shall I write that? Equation 3. Better I write since these are saved. Equation 3 and give a star here. Star. And star goes here for explanation. So this same. So you are all set here. Now B0. This is always valid and this is. So again, so what you get from this? From these two equations, so comparing these two, how to get or HB weight percent, we check this. Please check this. AB, follow these two relations. This is AB, left hand side AB, So same, they are same. So HB weight percent will be, and gamma B0 cancel. Gamma B0 cancel, AB cancel. So what you get HB weight percent is, let me write, and then you will check atomic weight of A plus 99 atomic weight of B. This goes this side. Atomic weight B, and another cancel what? See, atomic weight of A and atomic weight of A cancel. So what remains here? 99B. Okay. Atomic just I give you the result. H weight percent is what then? Now, shall I show you steps? This is better, na? Instead of I can show you this exactly. Follow. So you write here comparing the last two relation again. Just last two. Comparing. If I don't have space, I'll go to the top. If I don't have space here, because there will be difficulty in actually the video doesn't capture below this. So anyway, comparing the last two relation. Easy. AB. So right hand side same. Write that out. Gamma B0 is better. I didn't want to disturb very nicely. It is actually I'm almost done. So but still actually I have to. Which one I have said this? This is okay. Just I mean this one I'm retaining this one. This is very important. Understand? Same as okay. I am removing this. AB mole fraction over. So I am removing this. It is better comparing these two relations. You say left hand side right clearly. What you see? Gamma B0 write nicely. Gamma B0 first one you write. Weight percent B, atomic weight of A, atomic weight of C, Happy? See, just copy, and then you know very well what you write at the denominator. Weight percent A, atomic weight of B, atomic weight of C, plus weight percent B, atomic weight of A, atomic weight of C, and last is weight percent C, atomic weight of A, atomic weight of B. This is as you get this one, and the next one is this right hand side. Write this again. E equals to gamma B0, gamma B0, gamma B0. What is like nicely atomic weight of A divided by atomic weight of A plus 99 atomic weight of B. Okay, happy? Put it in bracket, and what is HB weight percent? HB weight percent. Just another line I will give you. What is this? So first you cancel what? Cancel. Then, and what you cancel further? Further atomic weight A cancel. So what you get then? Or HB mole fraction is already ready there, and I am trying to get HB weight percent. Then I will do something, some manipulation. HB mole fraction with HB mole fraction and HB weight percent. First I will divide. Let us see what I will do. So just HB weight percent. It is so HB weight percent. Extract this, or HB weight percent. Clean. What is HB weight percent? Tell me what is HB weight percent equals to. So this goes to the top. This goes to the top. Atomic weight C. Let us it goes to the top. Let it go to the top. Goes to the atomic weight of A plus 90. You check if I am making any mistake. This goes to the top. What else it is there? Atomic weight of C. Atomic weight of C. Atomic weight of C. C. And weight percent B is there. I am writing at the end. I am writing there. Just at the end. And then what I will write? This goes there, and this is there already there. Okay. So weight percent. Write this weight percent A, atomic weight of B. Very tiring though, but you have to write weight percent B, atomic weight A, atomic weight C, plus weight percent C. Shall I include? I think it is better this time at a weight percent C. Oh, I have removed this. I have removed this no? Already. Atomic weight of A. I don't have space there. Atomic weight of B. You understand? So this is HB weight percent. Very good. HB weight percent. Okay. Now, if you just, I wanted to prove something. I wanted to prove something. This is what HB weight percent. This is the no, not complete. What is missing? Weight percent B. So I badly need to write that one. Where I write. I have to write maybe. I write here. Wait a bit. It is better I sacrifice this. Give a bracket, weight percent B. This is very important. I'll show you. Actually, this is, and here you have to add another one which I have removed there. Atomic weight of A, atomic weight of B. Give this, covering this. Just compare with the binary. This is ternary. Okay. Now what is this? What is this? This is the Henry's law line equation in case of ternary. And if it was binary, it was not much different. What is the equation? See, HB8%, HB8%. And then what you had here, where it is atomic weight of A plus 99 atomic weight of B, and it is same but multiplied by atomic weight of C because C is present. Okay, and then what is the denominator? Denominator C, atomic weight of A, weight percent B. This is binary, atomic weight of B, weight percentage, but this will be ternary. So this type, this is the difference. So you may consider this H/8%. Now this is what is this? Right? This is the equation of the Henry's law line. So this you write this equation. So this is the equation for the Henry's law line. What was the equation of the Henry's law line I have given here? You see, the equations are elaborately written here. Henry's law line equation, binary. Now ternary. This is the equation for Henry's law line in terms of Henry's law line in terms of equation, three equations, Henry's law, 1, 2, 3. Since this is quite big and I didn't have much space, approximately 8% I wrote, but actually elaborately this, precisely this. So in terms of what? In terms of because in terms Henry's law line, this is the equation of Henry's law line in terms of this is the equation of Henry's law line in terms of HB8% versus 8%. This is what, see here, what is Raoult's, this one, AB versus XP, Henry's law line equation, AB versus XP, AB is gamma B0 XP. This is HBMA versus XP, and this is HB8% versus 8%. This is also HB8% versus 8% B, but for ternary. So versus 8% B in a ternary system, okay? For the ternary system ABC. Ternary system A, B, C. Okay. So I told you what? I told you what? How I got this? I got this what? I got this how? See, only only excluding this, accepting this 88%. This all same. See here. See, exactly same. So this also why this will be given? Can you tell me why this will be given here? This you have to arrive at. But I have arrived at exactly same, accepting 88%. Why I should give? This shows what? This is I've written somewhere. This is actually the deviation from. I wrote there somehow. This is actually HB mole fraction is HB 8% B. This is actually this is the Henry's law line, and when it is HB 8% is okay. While I wrote this, I have written here. Since I have showed you this, you are satisfied. HB 8% I have introduced because it is actually the deviation from Henry's law. Since HB 8% when it is relevant when this is deviation from Henry's law, means this I wrote actually, but I have okay, follow this. I have established up to this point, this and this. Where? Here. And when there is a deviation, so you see, if there is a deviation, so I should write this actually. I have forgotten to write. I have to write. How often I said proof I have written, but what is this? Write this. This I forgot to write. That's why trouble comes actually. This is the HB mode fraction is okay. See, I from the very beginning I have considered this. This is the deviation from Henry's law because I am inserted this. I inserted this. Now here also this is barring this AB8%. This is actually the equation of the Henry's law line as I have written. But if it deviates, so every time I am considering this Henrian activity coefficient means deviation from Henry's law. And Raoult's activity coefficient deviation means gamma b xb. This actually I have considered. Okay, see these things. Okay, so when there is deviation, so I should write here actually. I should write this is the proof is here. This is the equation for the HBMF is FBX. This is the equation. This is the equation. Short equation. What equation? For the this is the equation for the deviation from Henry's law. From Henry's law. Okay. Here I am writing from Henry's law. Deviation from Henry's law. Just remove this. This is deviation from in terms of HB weight percent. In terms of I repeat this. I repeat. Don't worry. Proof is here. Proof is here. Proof is here. Proof is here. Proof goes from this point. Oh, comparing the two relations. Give a star here. Star. Comparing the two relations as I have showed here. Star. Okay, good. And but this is not exactly this because this is the equation of the Henry's law. This is the equation for the Henry's law. These are the equations. Equation for the Henry's law line. The equation of Henry's law line in terms of HB weight percent versus weight percentage. For binary C, what is the equation? This is modified into this for ternary. Compare this. I repeat. You please do yourself. I am not writing here. I could have written this one here to see the difference. See what is HB weight percent? HB weight percent. Atomic weight of A plus 99 atomic weight of B maintained here times atomic weight of C here because C is there. And then denominator is changed because it is atomic weight of A weight percent B plus atomic weight of B times weight percent A. This should be weight percent A, atomic weight of B, atomic weight of C plus weight percent B, etc., etc. So this is Henry's law equation for ternary. I have written because of Henry's law line in terms of Henry's law line can be written three ways. Three ways. 1, 2, 3. 1, 2, 3. Binary. Ternary likewise. So Henry's law line. So this is the equation of the Henry's law line. But if there is a deviation, then we have to incorporate corresponding activity coefficient. That we have done here. So that's why I have explained what is this. This is not the Henry's law line. That is the deviation from the Henry's law line. This is the equation. I think I'm reading this. This is the equation for the follow slowly for the derivation from deviation. I'm very sorry. This is the equation for the deviation from Henry's law. Henry's law line maybe. I have space here. Henry's law line in terms of obviously in terms of what HB8% and weight percent B. In terms of HB8%. Okay. So this is deviations. So here suppose you ask me, sir, what is the equation is here. For example, here if you want to get the deviation, you will add the corresponding activity coefficient. Okay. So here I tell you, this is Henry's law line equation. This is okay. What will happen? I tell you what. If you want to, this you have done already. You have to incorporate Henrian activity coefficient. What is this? HB mole fraction is AB mole fraction times HB. Incorporate Henrian mole fraction, suitable. And here, this Henry's law line times, you have to write HB8% is this times AB8% times weight percent B, or at the end you write AB8%. So to take care of the deviation into the activity coefficient, suitable activity coefficient, appropriate activity coefficient must be there. Okay, so this is here. And this is activity is gamma B0 x Henry's law line. Okay, this is already a Raoultian deviation from Raoult's law already. But if you want to deviate from this, what will be the equation? Deviate from this deviates becomes AB is gamma B x. The gamma B is the activity coefficient. So these are all discussed. I am repeating to connecting back with the previous relation and also the current relation. So it's okay. So here please follow. I think you have got this. This is final. So this is the 1, 2. Follow 1, 2. Our aim is what? Tell me. I'm giving a box there. This is actually I have saved. This I have saved already. Just for comparison. Up to this point. First one is for the Ternary System A-B-C. This is okay. Right. This I have added. This now the relation. This also I have added. This is the deviation and this is the equation of Henry's law line, and this is the deviation. This I have added. These two I have added, and other things. And this is the proof. I wrote something. What is the proof? Proof goes from this to this. But why is the FB? Now, if deviation FB, you have to always this is the Henry's law line and deviation FB. So I told you once, point P, deviation from three lines. Point P, this state P. Point P means state P of B. State of B at P. This is the whole meaning. Given by temperature, pressure, and composition. Temperature, pressure, of course, this is drawn for certain temperature, pressure. So, this deviates from Raoult's law. This deviates from Henry's law. Both Henrian weight percent as well as both. Actually, what is this called? HB, Henry's line and actually deviates from this relation and this relation both. So what it will be? Actually, as I already told you that you have to introduce activity coefficient. This has been discussed. So actually, I am sorry I have introduced this, but I have proved actually without this, but should be for deviation. Mark the word deviation, and this is exactly the Henry's law line equation in ternary, both for ternary. We are discussing ternary. Now the time has come to I go back to the top. So this is the best place to write on, utilize, best place. You just divide this from this last two relation where I am here. This is a proof. This is actually the one that we are continuing. This is the actually additional thing that is a proof in bracket proof. This is the proof. So I remove this. This is the proof actually. This is the equation for the proof I am giving this. Yeah. So continue with this. Now shall I give a name to this? I am not sure. I don't think. I don't think so. I don't think so. Yes. No. I should. Please. HB. Call this. Equation. Call this equation 21. Sorry, sir. Up to which we went? See, you'll see somewhere. Up to which 20. Last day binary 20. Okay. Now 21. Give this 20, 21. And obviously this will be what? This will be what? Tell me. 22. 22. So these are the new things today. These two equations are there. Others are short equations. I have not named this. These two. So comparing rather. Okay, comparing. 21, 22. Okay, from 21. From where I am writing? From where? Actually, this is a proof. This is equation for the division. Maybe from this double star. This is the proof as corollary. This is the corollary part. Proof. And you see, you get this. So start from this. Double star. From equation, tell me 21 and 22. What? Please tell me. You divide. Please divide. HBMF divided by HB weight percent. You get what? Do this division. FBMF by FB weight percent is FBMF by give a bracket. They are giving bracket. Looks better by FB weight percent plus you see now you see numerator denominator same. Denominator weight percent A atomic weight of B atomic weight C plus weight percent B etc. Weight percent A atomic weight of B atomic weight C atomic weight of C plus weight percent B atomic weight of A atomic weight of C etc. So they are exactly same. Cancel out. So what remains? This by this weight percent B will be there and also atomic C will cancel out. What remains then? Atomic weight will be on the top times atomic weight in the top and denominator atomic weight A plus 99 atomic weight B. No doubt about it. Take a look, please take a look and you may argue, sir, weight percent B, sir. Yes, sir, weight percent B here. Weight percent B, actually remember this time I had a difficulty writing weight percent. However I write, it will be weight percent B. This weight percent B, cancel. So perfect, very simple relation. Very simple relation. Now recall, what is the key? What you recall? Now you recall from here. I'm writing, you recall here from C, this side. HBMF over HB weight percent. HBMF over HB weight percent is what? Last line. is atomic weight of A over, right, atomic weight of A over atomic weight of A plus 99 atomic weight of B. See here, this is what? This is actually, again, standard state situations. This Henrian activity of B in the Henrian activity standard state, mole fraction, Henrian mole fraction standard state. This is Henrian mole fractions. Wait, I'm sorry, Henrian weight percent standard state. Mole fraction standard state, weight percent standard state, Henrian. So this is already set. And this is actually, these are always true. I repeat, these three relations always true, does not know ternary, quaternary. Their origin is binary. They are defined from the binary system. Defined. As I've said, activity of B with respect to this, activity of B with respect to this, activity of B with respect to this, symbols different. In one case AB, Gaussian, others are HB. And sometimes actually subscript, mole fraction, and another HB with us. Three symbols. The relation are fixed, binary, and cannot be changed, or cannot be affected by the actual size of the system, whether it is 3 component or 4 component, 5 component does not matter. So where I am, I'm cancelling. Oh, I've got this. Since comparing the last two relations, where I am here I am. But recall, this is this. That means this equals to this. That means this equals to this. So AB mole fraction divided by AB weight percent is 1. Means they are equal. And before this, I have not removed, I believe. I have not removed, or maybe weight percent I have saved there. And AB mole fraction for the ternary in the first phase discussion here today, gamma B by gamma B2. So value is known and they are equal. So they each have the same value. And more importantly, they have the same relation as binary. This is the message. So let me finish this. I actually have to remove this part. This is no longer needed. In fact, these are no longer needed. Just I'll remove all these things now. So from the recall this, hence, tell me, okay, this is, let me check whether there is any equation number. It's atomic weight by 1990B. But this is also, what is this equation number? Can you tell me what is the equation number? Tell me this equation number. 15. 15 have it. Because it depends on the binary, because the origin. 15. And what is this? The new one, New one. So new one. I don't have, I have a space here. What is the equation? The equation is every fraction, etc. This equation, tricky stuff. 23. So shall I get space? 20, 1, 2. I'll write it short. 1, 2, 3. In fact, activity I can write here, no problem. In fact, I will remove all these figures soon. Activity off. Don't worry. And this fencing is there. This figure, about the figure, this side. 20, where we are? 22. Last one was 20. 22 somewhere. Okay, I forgot where I wrote actually. Yeah, I see here. 22. Okay, and there 21. 21, 22, 23. 23, where I wrote 23? 23, here I wrote. And this is 15. This is 15. 15 is old. 15. 15. 13. Hence, from 23 and 15, we have AB mole fraction is AB weight percent. Even for the AB mole fraction is AB weight percent, still valid with the ternary, still valid. Valid binary, valid binary, still valid with the ternary, still valid with the ternary system. And what is that value? What is value? That is, hence you can write this clearly. AB mole fraction value is given here. In the AB mole fraction part, value was obtained. And now you see they are same. So this value will be applicable to either of them. So AB mole fraction is AB weight percent is gamma B here. Gamma B here. Gamma B by gamma B0. And remove this, please remove this. All you remove, in fact, all. This is the about the last line. Hence, what equation this? This is, don't give a new equation, already T20. Same I am writing. That is, go for ternary binary, still relation same. So, 20, equation 20 here, okay. So, let me write this finally, okay. So, for this is so for ternary system ABC, and in fact, remove this, all remove. And in fact, for any, you have understood by this time it is for any. This one I am writing ternary, you write quaternary, and that equation will you have A, B, C, D. But cancellations, all these things are come. Right? And in fact, for any multi-component system, and for any multi-component system, you see, and hence for ternary, and in fact for any multi-component system, for any multi-component, in fact for any multi-component system, okay. In for any multi-component system, once more write this same thing. AB mole fraction is AB weight percent. As well as binary, add this, as well as for binary system. Anything binary was covered last class. Today I am considering ternary, as well as for binary system, AB mole fraction is AB weight percent is gamma B by gamma B0. Maybe there are some confusion in some textbooks about these two relation. For binary, even for binary. activity coefficient relationship. Mole fraction and weight percent. Henrian, mole fraction and Henrian weight percent. Okay, Henrian activity coefficient. Maybe there are some confusion maybe. Okay, but this is clear. This is clear. Clear. You just again. Clear. Important. Important. So thank you. With this, I have completed alternative standard states. Now the time to take up what is this called? Assignment. That will use alternative standard state concept. So that is very important. So now we'll move on. Okay, and I will remove all this, totally clean. This figure will also go away. So let me do this. So I'm removing this. All. Oh, I will remove this. Okay, I will remove this. Achha, this is not bad. This is not bad. These are not bad. And figure I will remove this. Figure I will remove this. Or maybe I think I don't. I cannot afford to, because I have to draw more figures. For each problem, I have to draw figures. Only I will retain this and this one. Okay. This standard is no use. No use. This is remove this. Only this. Okay. This figure. All remove this. Clean, clean, clean. Audio standard says solution thermodynamics continued. This figure was very important to show the standard states and the discussions and and the related discussions, all discussions like the Henry's law equations, different forms, Henry's law equations and activity, okay, standard state, different standard state activity relationship, interrelationship. So very important figure to understand. So you may actually save this figure. Just I kept this, remove this also. So start. Assignment number, as I tell you, assignment number. This will be assignment number, you know very well. Assignment solution thermodynamics. Assignment number 10. 10. Okay, based on, right, alternative or the problems based on alternative standard states. Problems based on alternative standard states. Start problem 1. What it says, problem 1. Let us propose two alternative standard states two alternative standard states. For B in the solution, for B in the solution, AB, A is the solvent, B is the solute, as we consider at temperature T Kelvin and P atmosphere They are point P at xB is 0.4. Achha, I sketch the diagram. Time. This is Raoult's law line. This AB, Raoult's activity. XB moves from 0 to 1. BC may call A as before, call B. 0 to 1. What is the Raoult's law line? Not. Yes, okay, better. This is Raoult's law line, okay, better. Okay, what is this? This is R, the Raoultian standard state. AB moves from 0 to 1. XB is okay. Now 3 points P, XB. This is M, corresponds to 0.5. P, M, Q. This is 0.6. This is 0.4. P, M, Q. Now I will explain what is Q and what is M. Okay. R is the Raoultian standard start. Okay. Now AB, okay, at T Kelvin, T atmosphere is diagram drawn. Okay. What is this? There are points P at XB is 0.4 and point Q at XB, XB is 0.6. So we are alternative standard state we are considering 0.6, both lying on right. This is Raoult's law, right? Raoult's law. You know this AB is XP, equation for Raoult's law. Both lying on the Raoult's law line. line. Okay, this I am writing here also. AB is XP as shown in figure 1. As shown in figure 1. Figure 1. Okay. So what else? What else as shown in figure 1? M is another point. State rather. M is another state of B actually. Is another point. M is another point at XB is 0.5. Is M 0.5. So straight. Straight. Another point at XB is 0.5 on the Raoult's line. On Raoult's line. Find A. Question. Question A is what? What is the value of? What is the value of? What is the value of delta G0 Q to P? That is G0P minus G0Q. Question mark. First question. Second question. What is the activity of B at composition M at composition M at composition N with respect to P M Q R each as standard state. Standard state. Another thing is given here. No, nothing. No, it's okay. This is the problem. Whole problem. So see, we are proposing standard states. We know what. So far we have come across three standard states. One is Raoultian. Another two is based on Henry's law, Henrian standard state. But today we are proposing new standard states. Actually, the choice of standard state is arbitrary and a matter of convenience. Just play with this. Play with this to be expert in this. To have full command of this standard states, alternative standard state. See, so here what we have done, what are the standard state I have considered? One is P. P is the standard state. R is the not. R is the Raoultian standard state. But we have introduced two. One is P. The state at P is the standard, new standard, and yet new yet another new standard Q. This is the first question. Then ask, what is the difference between the free energy of P and Q? Free energy of this and this, since they are called standard, so we will actually give superscript 0. Called standard, but we will write this is actually the standard state P and standard state Q. Keep this. What is the free, means what is the free energy of this state and this state? A symbol is G0P minus G0Q, since they are actually chosen standard state. Symbol is not so difficult. It's not so okay. So not so okay. Is not so okay, troublesome, or say what should I say? The symbol does not matter so much. Does not matter so much. It's not so important. The symbol you can give. You will understand what it is. What is this? The free energy of P. Why 0? Because this is actually standard state. Henrian standard state. G0H. HSS. Henrian standard state. G0. Anyway, don't worry. So, but mainly the difference between this and this. Next question is, what is the activity of B? Obviously, the activity of B at this state. Question should be proper. Activity of B at composition P, I'm very sorry, at composition M. What is the activity? With respect to 4 different standard states. With respect to 4 different standard states. See, change the standard state, activity changes. I show you this. This you always follow. This line I am writing you. Gi bar, remember I told you Gi bar is Gi0 plus RT ln AI, or Gi bar minus Gi0 is RT ln AI. What it says? See, the moment you Gi bar, giving free energy, you change this, AI changes. You change this. You change from what? From R to A, Q to M, free energy. These are all different. So that, if this changes, this remaining same, so activity will change. This is obvious. So find the activities. What is the activity of B? Add this composition with respect to 4. 4 answers will be coming in the second part. First part only, start. Achha, remember this. I repeat you, very important, never forget. Gi bar is Gi0 or tail in AI. Never forget what I said. Activity, AI means activity always refers to a standard state by definition. Because AI is, I should not say all these things, AI is Fi by Fi0. Because this, so just, you don't have to go back to the fugacity, but it says relative to. This is a standard state, this is a state under study. This is a state under study, this is the standard state. You may write that, state under study for preliminary understanding, for easy understanding. But to begin with, you consider this is the standard state. This I am repeating just to refresh your memory. Standard state. And then what is this? Activity of this state relative to this. This is the whole meaning. Activity of the state under study. Activity of the state under study relative to this. These two can be actually, you can manipulate hot like this. You can consider this one. This understudy can be another standard state. This I told you previously. And today I will often use this. Always follow this. Gi0, one standard state with respect to this anything else. Suppose this is a Raoultian standard state and you write here Henrian. So this will be treated as Gi bar, the Henrian one. Because anything other than this will be treated as Gi bar. I will again take up this and explain. You have need to this. But first follow these standard relative to standard state without mentioning reference standard state. Don't mention activity. This will be wrong statement, or this will be okay confusing statement, or this incorrect statement, not acceptable. Where there is activity, there is an reference standard state. What is the reference standard state? This activity of what? Activity of I at this state, gi bar. Enough is enough. Solution. A. I am writing C. Delta G0 I am writing. Delta G0 Q to P. If you follow with me, you will understand. And then you will enjoy this. Okay. By memorizing, you cannot do anything. Thermodynamics, you cannot do anything by memorizing. If you have understood, suppose you have understood, then you can memorize. Oh, okay, how to memorize are like this. For quick response, quick action. Otherwise, you can derive derive this relationship yourself. No. Okay, G0P, what is this? This to this, product minus reactant acid. This means this. Okay, see, Q to P. I'm explaining this. Why? What is delta? Delta G, product minus reactant. So product minus reactant. The meaning of this. This. Now how will you get this? This is to be found. This is to be found. What I'm doing some manipulation. Follow this. G0P minus G0R. Gaussian. Follow. Minus. Oh, this is G0. This is G0. I'm sorry. G0 given. 0 is given because there are actually some new designated standard state, some chosen standard state. They have been honored as standard state. But we know very well, not, but it's not Gaussian. Gaussian is here. Henrian is still another. On the Hindi slow line. Minus G0 Q minus G0. No problem. Now what you see? What is this you tell me? G0P minus G0R. You just, or you are writing alternatively, Gi bar minus Gi0 is RT ln AI. Okay. This is as good. These two same direction I am just transpose. Follow me. What is this? How will answer this? G0P minus G0R. It is like this. You follow this relation. It says Gi0, suppose this is Gi0. Then this G0P is what? Gi bar. Anything other than this will be treated as those standards. You don't care. Anything other than this is Gi bar. This is Gi0. This plays the role of Gi0. This one will be anything other than Gi0, also it is Gi bar. This will be Gi bar. Anything else. It treat as Gi bar. Then it is a Gi bar minus Gi0. And what is the relation? Is tell me RT ln. This is RT ln activity of I is what? What is this? What is the question? What is the value of this? Okay. What is the value of the? Don't worry. It is activity of B. These are activity of B are given. Okay. Activity of B at follow Gi bar minus Gi0 is RT ln AI. AI of what? Of the state under study. This. So activity of B at P. If you follow this, then you will follow most of the things. Repeat. Gi bar minus Gi0 is RT ln. Those standard. This has happens to previously. Previously I explained this. I am repeating only. I am repeating. Very useful thing, important thing. Maybe repeated. Maybe helpful if we repeat. So this treat. Suppose it is your Gi0, then this is Gi bar. What is the answer? RT ln AI. So what is it? AI is what? activity of I, follow the arrow, activity of I of this state relative to the standard state, with respect to the standard state. So activity of B of this state P relative to Raoultian, relative to R means the Raoultian standard state. Hence, what symbol I have used here? Since it is related to Raoult's, shall I write another line? Is I am writing another line? RT ln A I am writing. See, follow ln A I am not, A is a symbol. I am not writing on purpose. I know it should be written A because it is Raoultian activity. Henrian H. But if I write ACTIVITY activity, spell it, then you write which symbol it should be, not bad. RLN, since Raoultian is very common and very convenient standard state reference. So, but anyway, I am writing at the beginning, activity, tell me, is a activity of this relative to this, with respect to this. Activity of B at B is the species, at state P, at P means at state P, at state P, at composition P, state P, at with respect to tell me G0 with respect to this standard state. Activity of this with respect to activity of this with respect to this GI bar of this with respect to this. With respect to this means Raoultian standard state. So minus similarly right. RT, first problem I am giving you time. First problem. Follow this, otherwise you will not be able to crack these problems. Do well. Okay. Minus similar, tell me RT ln, again write that. Activity, as if you don't know. Simple minded activity. Then I will see symbol later on. Next slide. Think of activity of B at state. What is this Q? With respect to Raoultian standard state. What is the now you write in a simple way. Oh, since with Raoultian standard state symbol is A, it is better to write AB short ln AB at P first minus RT ln AB at Q. Can you tell me now what is RT? AB is what? 50. Oh, okay. Let's see. Anyway, it will take 10 minutes, maybe 10, 12. What is this activity of B? Tell me, can anyone tell me what is the activity of B? What is the equation? AB is XB. So XB, actually XB, you can write XB back, but that is not good. XB. B is the species. XB at P. Good. AB is XB. Raoult's law. On the Raoult's law line. We know this. It is written also. Minus RT ln AB is what? XB at Q. Then you write this RT ln XB at P is what? Tell me. 0.4 minus RT ln Q is what? 0.6. Our answer is RT ln 0.4 by 0.6. It is RT ln 2/3. Answer. T is not given. T is T. If it is given, you can put the value. R is 8.314 joule, and it's the answer. What is the question? Delta G0 answer. Answer what? A. Quickly. B. Now you have to find the activity of. So you see, after G0m minus so one thing you follow this, you recall I said what? Suppose when you are handling two standard states, in fact you have already handled, but this question was different or something, it is different. Recall Gi bar is Gi bar, remember? This knowledge, these two lines knowledge of these two, command of these two lines and these two lines I am writing. Essential to handle alternative standard state. Gi bar is Gi bar, recall identity, Gi bar is Gi bar, or Gi0, what you will get? Gi0 or TLN activity of I, okay. Gi bar is Gi0 or TLN activity of I. What standard state? With respect to standard state 1, say. Standard state 1. Gi0 standard state 1. With respect to standard state 1. 1 goes to equals to what? Similarly, the right hand side also. Gi0, I am giving standard state 2, second standard state, plus tell me a TLN activity of I with respect to standard state 2. This you have to remember. This you will use often. So I'm for example I'm using this. You try to follow here. GI I'm writing this RTLN activity on RTLN. Acha. I'm writing this and these are together. I will group together. These and this I take to the right hand side as minus and then I will add RTLN activity of M, activity of M, activity of B at M, at state M actually, with respect to Raoultian standard state. Follow this. Exactly this I have done. Exactly this. Follow this. Always you do this. This follow this. RTLN activity of B at certain state, activity at M with respect to I consider this is one is Raoultian standard state. Say Raoultian standard state has some advantage. I will explain. Raoultian standard state. Then so this this standard state, this is there on the same side. G0 1 standard state. So if we transpose this goes to the left hand side as G0 R, means standard state 1. G0 R plus this. So this is what is written here. So that's what this goes to this. So this is Raoultian, this is Raoultian. Hey, see here, this is standard state 1, this is standard state 1. One side. Another side is similar, standard state 2, standard state 2. G0 standard state 2 are TLN activities with respect to the standard state 2. So here also, if you take this side, this is G0 Raoultian standard state and plus RTLN activity of B at M with respect to activity at M with respect to always with respect to Raoultian standard state. G0 R means G0 R, what is this? With respect to Raoultian standard, because this is G0 R, so actually this goes to this G0 R plus this goes to this G0 R. See here, plus this. So I am removing this here, and this other side is what? Tell me. RTLN second standard state. RTLN activity. Don't give any symbol. Here actually I have not given symbol, but I could have given, because it is Raoultian standard state activity means A. Coming later. RTLN activity of B at M again with respect to P as the standard state. So if it goes to the other side, see this plus this and this plus this, like this. See G0P standard state 2 plus RTLN activity of B with respect to standard state 2 means P as the standard state. So clear? So this is coming from this. Actually only I have collected these two standard energy 1 and 2 together, and one left hand side is along this, right hand side this along with this will be there. So this now easy. This is it. Your question is what? Question is this: what is the activity of at M? What is the question? Activity of B at M with respect to P as the standard state. P, then M, then Q, then R. 4. Start with P. This is the question. So if I know these two, this and this, then nothing like that. Or write nicely, Ellen. Please tell me, with respect to Raoultian standard state means very nice. Raoultian standard state. What I write? A, just to give you some comfort, or to you comfort yourself, that activity of B. A, Raoultian standard state A. B, at where? At M. No problem. RTLN activity of B at M. That you know actually. Coming to this. What is this? This is very interesting. See, here you use this one thing and another thing. Come back, go back there. After this section. Okay. G0, 5 minutes more. G0 P minus G0 R. So again, as I told you, if you consider G0, gone. Just now.
Last one is a bit.
2 ঘন্টা বেশি যাচ্ছে না,
এটা আছে
যাচ্ছে শিওর তো? 2 ঘন্টা 3 মিনিট শিওর বললে তো।
লাল ক্লিক করছে, আর এখন আবার তাও নেই। এই তো দেখেন,
আস্তে আস্তে কথা করবে, আস্তে ভালো লাগে কাল